All right. Today we'll show you a hands-on example of a C++ program that will help you to understand the assignments you have in Lab 8 and Lab 9. Understanding this part of the class is extremely important because the final will cover Lab 8 and 9. So before we start, we first try to understand what is a programming language. What is this about? Because we have worked with Microsoft Word, Excel, and Visio, and most of those were pretty much straightforward to understand that what is the purpose of those applications. Now again, this is also an application, but most of the people know it as a programming language. As of today, this is one of the most famous programming language the world has ever discovered. Now, by the programming language, or using the programming language, we write programs. The purpose of writing program is to do some operations using the computer. Now, what is the difference? We don't understand it yet. For an example, let's say, let me make it extremely simple. Let's say you have a formula to calculate the area of a circle. I think we all know that formula, right? And you know that if you know the unknowns, right, or the variables, you will be able to find the area of a circle, right? The only variable you might need is the radius of a circle. But let's say you are trying to find the area of a circle and I gave you the radius. You can just do it in your calculator probably within 30 seconds or probably 15 seconds, right? Now, let's say you have to find the area of 5 circles. When I'll give you 5 radius, you can probably still do it, right? You probably need a little bit more time than 15 seconds. How about if I give you 50 radius to find the area of 50 circle? I'm sure that still you can do it, but it will be a little bit boring than the earlier ones. How about if I give you 500 radius to give you to calculate 500 areas of 500 circles? It will be extremely boring, and there is a chance that you might make a mistake. I'm not saying that you don't know the formula. You know the formula, you have your calculator, but there is a chance that you might enter the wrong values, right? How about if I give you like 5,000? How about if I give you 5 million? See, that is the time you will need a program to help you out. For an example, let's say if you write a program here, a very simple program can calculate the radius of a circle. Or, calculate the area of a circle given the radius. So the purpose of the program will be, it will ask you every time when it will run, it will ask you the radius, you will enter the radius and it will calculate the area for you. What is the difference here? The difference is basically making your life easier, because it doesn't matter how many times you want the area to be calculated, it can do the job, right? It doesn't need even 15 seconds. As long as you just enter the radius and press the enter, it will just give you the answer right away. Probably within 1 picosecond or probably less than that. Right? And every time there is a guarantee that it will give you the right answer. As long as it gave you the right formula. It depends on you. So that is the reason we write the program. Now, if you look at carefully that your life right now, today, doesn't matter who you are, doesn't matter what you do, your life absolutely is dependent on all these programs, but you don't realize it. For an example, all the cell phone apps are programs. Okay? All the computer applications, doesn't matter it's a web application like Facebook, Twitter, or doesn't matter it's some kind of other applications where you download the software and install it in your computer, like desktop computer. All of those are different kind of programs where people have written the codes for you, they compile it, and they started a business, or they opened it for the public free. But all of those are programs. For an example, what happens if you don't have all the apps today? It's not probably believable that we don't have any apps and we are running our life, right? Somewhere or the other we are using apps. Doesn't matter whether it's a game or it's something else. Some of the apps are extremely important. For an example, let me give you another quick example. Let's say, what is the purpose of GPS? When you give the destination and it knows where you are, when you give the address of the destination, it just finds you the route, right? Can you find the route? You can, right? Let's say I give you the map. I tell you the address of, for an example, the destination and your address. Can you find it? You can also find it, right? So now tell me, why you didn't need the GPS then? It's extremely easier, right? Just think about that. Let's say you went to some city, new city. Even if you're in Memphis, you don't know all the places, you don't know all the addresses, right? Every time you have to find the address. People have found their addresses. People have reached their destination even when we did not have the GPS, right? Now, how did it change your life? Because it made it so accurate, so perfect, so fast. That basically bought you, okay? That basically changed your life. GPS is nothing but a software, which is just like a program we can write here. Now, remember, this is not a programming class. So, but I know that some of you are in computer major, and you will be exposed to some kind of programming for sure, at least at Southwest, or later for sure, if you keep exploring. But this class is not dedicated for the programming, so we don't want to spend a lot of time here, but I'm just trying to make sure that what is the purpose, because I have seen when you try to write your code and you raise your hand, I go to you and I try to help you out. Most of the time it seems like that we are not sure that what is the purpose, okay? That what is the purpose of doing these programs? The purpose is, let's say, I think some of you started, right? Some of you are at the middle and some of you already finished number 8, but some of you are starting, I think, number 9. Both of the labs are based on C++. So as you have probably noticed that in each program, somewhere or the other, we are calculating something, right? For an example, we are probably taking a couple of weights and averaging them. We are taking different miles per gallons of different vehicles, cars, right? And then we are calculating the average, right? Or we are taking radius of a circle, calculating the perimeter, circumference, right? Somewhere or the other, we have some kind of formulas. Now, the purpose is you are just trying to enter the formula into the program so that your program does the calculation for you and show you the answer. Now, what is the benefit? The benefit is when you are programming for the first time, it takes you a while to write the code, right? Because you probably have to write like 20 lines of code just to make this program working, which will calculate the circumference of a circle or perimeter of a circle. Now you might think, oh, okay, I can do it probably for this 15 seconds to calculate. I can calculate a perimeter of a circle for 30 seconds or 20 seconds. Why do I have to spend like an hour to write the code? Ask yourself, when you will have to do this for 5 million times? How about that? You are just spending 1 hour here, and for the rest of the life, This will be the program that will calculate the radius for you. Not even that. You can automatically do that for 100 times, million times, without even running it for multiple times. Just run it one time. It will automatically keep asking, do you have any radius? Let's calculate it. Do you have any radius? Let's calculate it. So that's the basically job of the program. Now let's look at a couple of simple programs and see whether we can understand it a little bit better. Remember, again, as I said you in the middle of this lecture, that this is not a programming class, and the intention is not to understand the programming. People have spent years and years to understand the programming. I have seen some famous writers who has the highest number of books written on C++. Herbert Schill, I'm not sure whether you have read any of or seen any of his book. Herbert Schill, so he has published 26 books on C++ as of today. He is one of the most famous author in this area. But before he has started writing his first book, he has worked on C++ for 13 years. So you can spend your whole life on it. Okay? But at this point, we are just trying to see whether we can at least get it started, or we can get little motivation or inspiration to feel the importance of this programming language. Now let's look at a couple of hands-on examples. Okay? Now this is the environment or where you basically type the program. So the name of the software is Borland C++. There is another one which is called Turbo C++. So both of these softwares are not free, so somewhere or the other you have to purchase it. Maybe you can buy some discounted version when you go to the discounted store for the students. If any of you are interested, just let me know. I have a discounted store link for the Southwest. I know that some of you probably have it. Now, let's try to look at one. Sure. I'm not familiar with that, but the basic idea is, you see, these kind of programmings, I'm saying you can do it, this kind of writing the code in different places, okay? But at the end of the day, you need a compiler. The compiler is something which basically translates your program into machine code, which is understandable by the machine. I'm saying by the desktop machines, okay? Now, you might have different kinds of editor, but the compiler must be either Borland C++ or Turbo C++, because this is the only two C++ compilers as of I know. And there are some Visual C++ compiler, but the basic C++ has only these two kind of compilers. Okay? So, but the editor can be anywhere. I'm saying if you are like an expert programmer, you can even write your program in Notepad, and then later you can paste it here to compile. At this point, we are just beginners, so we want to see the colors. Remember, when you type the program, if you look at carefully, have you noticed the color gets changed when you type different things? We don't understand why the color is changing right now, but I think after this lecture, we might get a little bit better understanding of colors, because those colors indicates a lot that what you are writing and how it understands what you have written. Okay, so but you can also write the program in Notepad where you will not see those color changes. But when you paste it here, the color will be changed. You can run it right away if you have written it right. Now let's look at some example. Now, any program, doesn't matter what you write, any program start with, I just made the font a little bit larger so that you can see. I'm not sure whether you can see it. Can you see what I'm typing? Now, any program starts with a function called main. Just by the name, there's a main function, right? And any function in C++ has to have a name followed by two brackets. And I know that you might I know you have already started writing the program, but remember the C++ is a case-sensitive programming. Okay, don't try to change the cases. Most of the instructions, I don't think most, all of the instructions here are in lower cases. You see, I write everything in M-A-I-N. It's in small letter. Don't think that, okay, let's make it a little bit more nice. Let's start with a capital M. No, it will not recognize what you have written. Okay, so the C++ is a case-sensitive programming. So anytime you're writing any function or anything, make sure you write it everything in a small letter, unless you have some variables that you are defining. In those cases, you are free to use any letter. I'm saying any case, upper, lower. Okay. Now, okay, so we start with a program with something like this, and then we put two curly braces. These curly braces will mean that, let's say the first one means that you began the main function, and the last one will mean that you stopped or you ended. Because the compiler has to know where you started and where you ended. That's something like beginning and ending. Okay, so anytime you are, this is the main function. So in this class for lab 8 and 9, we are writing all the programs, all the subroutine, I'm saying all the codes inside the main program. But later on, if you are exposed to other programming class here, or later if you go for programming, you will see that main is a program function, but you will have other functions too. Anytime you are writing a function, you will start and end with a braces, okay, curly braces like this. Now, at the beginning of your program, you will define some variables. Okay. Now let me make it a little bit simple. Let's say we are trying to write a program to calculate the radius of a circle. As we just mentioned. Okay. Now think about that. To calculate the radius, what do you need? I'm sorry. To calculate the area of a circle, what do you need? You just need the radius or diameter, right? You need the radius or diameter, right? Let's say for time being, let's make it simple. Let's say we just need the radius. Because at the beginning you think simple and then you make it complex over the time. Let's say you just need the radius. So to calculate the area, you just need one variable at this point, right? Which is radius. Now let's define a variable called radius. Okay. Now we know the name will be radius, based on our understanding, because we want to make the name of the variable as meaningful as we can. For the variable radius, you can either just use R, right? Or you can write radius. Now which one you prefer? Probably the R is good because you just make it simple, you just write R, right? But it's not good enough, because why? Later on, let's say after 2 months, when somebody else will read your code, or if you just go back to your code, you might forget why you have written R, because R represents a lot of words. But if you write radius, later on, anytime you come back, you will understand why you have written radius. You know what I'm saying? So that's why you sometimes will wonder why people are writing, because I have seen people have written variable name like this long, 20 characters. You'll be surprised at why. It's something they have written like, okay, area calculation for this variable. You might wonder that why they need so long variable, because you can just write one single letter. They try to make it more meaningful, because at this point you're writing a code for 20 lines, or 30 lines, or at max 50 lines. But people are writing code for million lines. The Windows 98, remember? There was operating system Windows 98 before XP, before Windows Millennium, before I think that was Windows 98. At that time, the people, I'm saying the Microsoft people, they have written the code, and it was like 3 million lines of C++ program. Now, it's more than that for sure. The XP and then the Windows 7 and Windows 8. People are writing the code still in C++. Now, so when you are writing that long program, one name of the variable is extremely important to understand, because it's extremely easy to get lost when you see a code of 3 million lines. I don't know whether you will ever see those kind of code. But, that's the reality. You will see a lot of codes if you are really interested for programming in future. Now, let's have an example. Here, let's say our variable name is radius. Let's make it radius. Okay. Now, look at this. I made the R capital. This time I can use my own case, because I can choose my own case in case of variables, because it doesn't matter what kind of letters, because I am free to use all letters, but I cannot use any space between here. Meaning, let's say I want to use radius 1 for an example. Okay. Let's say my variable name is radius 1. I can write radius 1 like this. I can write radius 1 like this. Okay. But I cannot make the radius 1 like this. Do you see the change in the color of 1? Why is that? Because when you put a space between radius and 1, your compiler assuming that radius is a variable, 1 is a number. It's not radius 1. You see the color change? Because it recognizes the radius as a variable name, or 1 is a number. So it's assuming you are writing 1 separately. You see what I'm saying? So the spaces is not allowed in the name of the variable. Even you cannot use this. You see the change in the 1. Why it is not valid? Can you guess why the hyphen is disregarded? Because some people might think, okay, still we are writing one word, but what do you think? Any guess? Because it might confuse the compiler, because we use the hyphen as a minus sign when you write the formula. Now, when you are allowed to use the hyphen as a variable name, your compiler will be confused that are you writing a minus sign, or are you writing a hyphen for variable name? That's why they intentionally eliminated that ambiguity, so that you will never use any hyphen in the variable name. So you cannot. You see the color change there? Because it recognized that you are writing radius minus 1. It's not radius hyphen 1. Automatically when you press hyphen, it assumes that you are just writing minus. Okay? Because anytime if you have something which has double meaning, everybody will be confused, right? Because you have to think, oh, okay, is this a minus, or it's a compiler, it's not human being, right? It's not intelligent like us, so it always assumes that you are writing a minus sign. Now, so we know that we can write radius. Let's stick with radius. I was just trying to show you that what kind of restrictions you might have. Now, one more thing, when you are defining a variable, you also need to understand that what will be the type of the variable. What do you mean by the type? For an example, as a basic math student, because we all are engineering students, so we understand some basic maths. Let's say we understand that some of the variables have can take only whole numbers, right? What are the whole numbers? Like 1, 2, 3, 4, 5, minus, -1, 5, 7, minus 6. All these are whole numbers, right? But there are some numbers which are fractions, like for an example 7.259. Those are fractions, right? So there are differences, different kind of numbers we have. Now in case of the variable definition, we have to tell the compiler that what kind of number it will take. Now can you guess what will be the type of the radius? Will it be a whole number or fraction? What do you think? What should be the best way to represent the radius? The whole number or radius or fraction? No guess? It must be fraction, right? Radius cannot be whole number, because we have like 100 different types of circles. Their shapes might vary. They might have some different. So we must have to have fraction, right? Now, for the fraction, we write float. Now what do I mean by float? Float is a data type understood by the compiler. Anytime you are writing float, that means you are writing something, you are telling your compiler that the radius is a variable which will take fraction. Because after a while you will be writing the formula for radius, right? Or you will be writing something else for radius. Then what do? You will know, or you will use some values for radius, right? For an example, you will enter some value for radius, and that value must be float. I'm saying fraction. So fraction is a data type for compiler, and that data type is called float. So just for time being, to make it simple, just assume that float means fraction. It will make you easier, just make it easier. Now, and notice one thing. We finish most of the lines, almost all of the lines in C++ programming by a semicolon. Do you see I just put a semicolon there? Now, first of all, why you need a semicolon? I'm saying let's try to justify it. You see, because you are trying to tell your compiler that this is the ending of the line. Unless you say it doesn't understand where the line is stopped. You might wonder, why not full stop? The plain English sentences, we finish it by full stop, right? Why not full stop here? Any guess? Yeah, you are right. Because you see, the full stop is a little bit confusing for compiler, because anytime you say full stop, it doesn't understand. Are you saying the line is stopped, or you are using a decimal point? 5.9, that's also a full stop, right? Again, we are just trying to justify that why they chose semicolon instead of full stop. They chose semicolon, there was a reason for sure. Okay. Now, so let's say we define the variable. We know that the float radius is a variable. Now, let's say what else you need to calculate the area. What else you need? You need pi, right? What is the formula? Pi r square, right? For calculating the area of a circle. The given r, the formula is pi r square. Any doubt? Anyone has any better formula? Okay, the calculating the radius of a circle. I'm sorry, area of a circle. Area equals to pi, right? Now you need the pi, but pi is something you will not entering from the keypad, right? Because the pi has a constant value, right? You know that, right? So now let's still we want a variable as a pi. Let's write pi here. You can write pi. Do you see I put a comma here because I'm defining another variable, but the type will be float. So that's why I can just use a float and then define all the variables. So let's write pi, pi, okay? But this time there will be a little change, because we know that circle to circle the radius will be different, right? But how about the pi? Pi is a constant number, right? So it doesn't matter what circle you are talking about, the pi will be same. So we just write here. Oh, welcome to Lisa Jones in our class, C++ class.
Good morning. Hey, look. Happy morning. It's raining up a duck. I just wonder.
All right. So the pi is a constant, and that's why we will write here.
Okay. Why did you put a space?
Oh, I did not put a space here. I'm just about to write something here.
No, after the radius, after the comma.
Yeah, that's just for nothing, because I am habituated to give some space after comma, because that's we do in plain English, right? After comma, yeah, there's something like that, but it's not required by the compiler though.
Okay.
So it's something like this. If you put a space there, it's basically ignored by the compiler. So it doesn't matter whether you put a space there or here, okay? But you know, some of the spaces are critical. You have to understand. So let's say the space between the float and the radius, that's critical. You cannot skip that space, because if you skip it, your compiler will not understand that you are writing float and radius. There's two different words, right?
Okay.
But after the comma, the space is not important because you already put a comma. You know, sometimes the common sense, which is extremely uncommon, is important. Okay. Now, let's now the pi is a constant, so that's why we'll write something like this. Look at this: pi equal 3.14159. So what we are doing, we are just telling the compiler that pi is a variable, but at the same time we know what pi is, and that value we assign to the pi will be same to the whole program. So anytime you write pi, your compiler understand that you are saying 3.14159.
Okay. So there's no
And you know, there is a
PI.
and there is no chance that the value of the pi will ever changing, right? We know that. So
Right.
we don't care. We just write the number. Now, excuse me. Now let's say what you are trying to write a program, right? So what do you want to write at the beginning? Let's say when someone runs your program, okay? Let's say you want to greet someone. So think about your user, okay? Let's say when you write a program, okay, when you run apps, what they do at the beginning, they say something like that, welcome, or they just show some images, you know. So let's say you are trying to greet your user, okay? So what should you write at the beginning? Let's guess. You know, this is not an assignment. Just think about it. Let it be creative. What do you want to write? Hello world? No, not hello world. I think. Okay, welcome to circle area calculation of circle, or what do you want to write? Okay, let's write welcome to area calculation of circle. Now, to have it displayed, because you want to display it right at the beginning. Now, to have it displayed, you need an instruction like this: cout. Okay, you need an instruction called cout. Okay, now you need to write an instruction cout, and with that we write something like this. Look at how we are writing. And here, within the code, we'll be writing the statement that we want to display. What do we want to display? We want to display welcome to the This is exactly, let's say, what do you want to display, right? And on that line, we don't want to display anything. That's the only line we want to display, and then we want to go to the next line, right? To do that, you will need to add and L. The and L is a line manipulator. Line manipulator is used when you are trying to move to the next line, to do something else in your display window. When you display it, you will display that line at the beginning, and then you want to go to the next line to do something else. Now let's say you want a gap of 2 lines. Okay, what do? You just write NL twice. Let's write NL one more time. Again with that sign, just write NL, and remember, we always finish any line semicolon. Okay, now let's move on. Now, what do we want now? So we already greeted, so we have to do some job for them, because you know we greeted them. So right now they are happy. So let's say we want to calculate the area of a circle. We know that. So do that. What do you need from the user?
The circle.
We have to ask the radius from them, right? We have to tell them, give me a radius, something like that, right? Now, to do that, what you are trying to do, you are writing, again, you are writing a line, right? So again, let's start with C out, because you are writing a line like this.
Every line starts with C out.
No. Every line where you want to display.
Right.
You are displaying, right? Now what do you want to display? Let's say you want to display enter radius. And then this is what you are displaying, that enter radius, okay? For an example, with a colon and a space. Now this line will show up, and after that, what do you want? You want the cursor will be prompted and will be waiting for the user to enter the radius, right? How to do that? So that means at this point, the user will enter something from the keyboard. They will enter a number, right? Let's say 21.6. And that number will be assigned to the variable radius we have here, right? Because we exactly take it as a radius for our calculation, right? How to do that? To do that, now this time we are taking an input from the keyboard, right? Meaning I'm saying we are taking an input from the user. How to do that? To do that, we write C in. Anytime you are taking an input from your user, you will write C in. Now this time you see the arrow signs will be changed. The arrow sign for C in and C out are different, right? That is the part of the syntax of C++. Now, the user will give an input, and that will be the input to radius, right? So that means we will write here the radius. So because the user will give a number which we will take as a radius. You see what I'm saying? Semicolon. Now remember, I think we have told you before, C++ is a case-sensitive language. You see how we have written the radius here, exactly matching with the radius we have defined. You cannot even change the R from lower to upper because it will not understand that. It will assume that you are using something else. Now, your compiler knows what is radius because it knows that the radius is a variable which is a float type. It doesn't understand that it's a radius of a circle. It just understands this is a number. Okay. Now we got your radius. Okay. We got the radius. Now what do you want to do? You want to calculate it, right? See, you want to calculate the circle I'm saying the calculation. You want to do the calculation and show the area, right? How you want to do it? You want to show the area, right? Now, to show the area, again you will write C out. You will write what? You will write area. Okay, just one more thing. Here, after taking the radius, you probably want to have a line gap, right? Because you will take the radius in one line and the next line you will show, let's say, the area of circle is this, right? To have a new line there or to skip a line, you always want what? So what we are doing, we are just giving line break, because we want to show the end result in probably after one line, right? Okay, so I'm sorry, there is a typo. End error. Okay, now we are ready to calculate the area, and then we'll display it, right? So what do we write? We write area of a circle, of the circle, right? Now let's write it. Area of the circle maybe we can also add here radius of a circle. Okay, let's put a semicolon here And then now area of a circle, colon. After that you have to show the area, right? How to show the area? You remember, the compiler doesn't even understand what is radius. Compiler doesn't understand what is area. Compiler only understands the variables and it understands the formula. So all you need is you have to write the formula here, because by the formula it will understand what to do and what to show. See what I'm saying? Now let's write the formula. What is the formula? It's pi r square, right? How to write pi r square? So let's put a bracket here and then write pi. This means times radius times, that's pi r square, right? Because all we did is pi times r. Okay? You know, this bracket is not important, but we just wanted to make sure that we are writing the formula within the bracket, but it's not important for the compiler. It's optional. It's up to you. But remember, don't forget that we have to finish the line with the semicolon. I'm sorry, the semicolon here. So we are done, right? Now we also want the program to we always write something like this, GETCH, something like this, just to make sure that the program wait until you enter something. Otherwise, if you don't write GETCH, that means get character. If you don't write that function, this is a built-in function. If you don't write that, what happens is you run the program, it will calculate it, it will show it, and the window will close. It will be so fast that you will not even see what will be the area. So just looking at the area, it will be a challenge. So just write GETH. Now so we are almost done with the program. Now once we are done, what do? We try to compile it, right? See whether there is an error. So to compile it, or we just click this one to run it. When you click this, that means it's compile and run, okay? Both at same time. We might have some error. Let's check. Oops. You see here, it found a lot of error, right? Why is that? Because all of this instruction you are writing, everything is right, but the only thing is you have to include some header files. Why is that? Because all these instructions and subroutines, the functions that you are using, those are predefined in those header files. So that's why before even you write any program, you have to include the header file. Now how to include it? To include the header file, you go at the top of the program, you write a hash or pound sign and then write include. You have done it, right? For each and every program you do it, right? Remember, you saw it, right? So, and then we put something like this. And then there are several header files. Not several. There are many header files. But for you, since we are doing very basic programming, so we just need a couple of basic header files. One of the very famous and basic one is the iostream.h, right? We have used it in almost every program, right? iostream. Now let's write io. Let's try to run it again. Oops. Alright, so we still need some other header file maybe. Let's see, maybe we need, we might need conioh. Let's try to run it. Look, our program is running. This is the first program we have written. So as we planned, right, at the beginning it greeted the user, welcome to the area calculation of circle. And then it asked, enter radius of a circle. Let's take a radius. What radius you want? Let's write 9.67. Okay? Just think about that. We just entered the radius, but we did not press enter yet. So the compiler does not know that you have the radius entered.
What did you change in your
Oh, I just added one more header file, which is conio, conio.h. That's a new IO. Yeah, you can see it. Let me bring it down. Can you see it now? Yeah, that's another header file. You know, these are very basic header files. You know, almost anyone who has written at least 2 or 3 programs in C++, they should know these header files. Now, we are entering the radius. Now, you see, just think about it. I will press the enter and see how fast it calculates the radius. Okay? Let's see. Let's press it. Do you see how fast it calculated the area? Can you do it so fast? You know, this is the point where the computer and program changes the game. This is so fast. Nobody will ever beat it, okay? At least we are not, for sure. You can do it. You can find the same area, right? But do you see the area calculation? Any doubt about the calculation? No doubt. Unless you enter the wrong formula. You see, it's waiting. Because of that, get CH. But otherwise, it will be a challenge to see the answer. Now, do you see how simple the program is? Because, you know, I'm just trying to show you that what is the purpose. Because, we did not even enter 9.67, 293.767 in the program. All we did was, we said, radius is a variable. We gave the radius, we gave the formula, and it had calculated it for you. Okay?
Okay, why can't you put pi squared? Why do you have to type radius times radius?
Oh, we wanted to make it a little bit simple. We can do the pi square, radius square too.
Okay.
We wanted to make it simple. You know, this is the first program we have written here, okay? So I wanted to make it simple because, you know, we can do the same thing, yeah. But
I was
yeah,
just
yeah.
wondering if you could do it like that.
See, we can do that. But, you know, we wanted to make it simple. So that's why I wrote pi times r times r, okay? If you want, you can make it extremely accurate. Instead of writing 3.1415 you can just write 22/7, which is the exact value of the pi. Okay, 22/7. That is the exact value of the pi. But the problem is when you divide 22 by 7, it never stops. And people did some experiment. They tried to see how far it goes. And so far as of I remember, people tried to get after the decimal point. They found all the digits up to, I think, 5 million, but it did not stop yet. If you really want, you can do that. You can keep going. I'm sure that if you touch the billion, you will see your name in the Guinness Book. That somebody found, you know, that's just a regular division. So it will keep going. Okay. It will never end. All right. So when you write 3.14 or when you write 3.14159, what is the difference? The more number of digits you have after decimal point, it will be more accurate, but it will not be the most accurate because, you know, it will never end. But otherwise, if you just write 22/7, probably you will feel okay. Yes, at least it's a little bit closer to the right because, you know, that will be the exact fraction. So now we have a basic program written. Now let's say we want to enhance it a little bit. Let's try to enhance it a little bit, okay? How we can enhance it? Add some flavor here. Now, what we can do? For an example, let's say there might be a situation that somebody doesn't want to calculate. Okay, now let's make a little bit more enhanced like this. For an example, let's say we want our program calculate as many area as possible. So that means we want it every time asking radius, we enter a radius, calculate the area, enter a radius, calculate the area. Because, you know, that's the beauty of a programming, that you don't write so many lines, but it will keep some lines will be repeated again and again. How to do that? So far it will not, but we can make it working like that. Now what we can do? Let's add a loop here. Okay, let's add a loop here. So let's say we have a loop called while loop. Let's make it always true. That means it will run forever, it will never stop. And let's add two curly braces here because of a starting point and ending point of while loop. Let's say, you see here, this is called some kind of looping loop, because sometimes what happens is when you write a program, you want some lines of a program to be repeated, okay, to be repeated again and again. To do that, we have some loops. This is one of the loop we have called while loop, okay. And in case of while loop, you have to write while, and within the bracket you have to write the condition for which it will be running true. At this point we have just written 1. 1 means, remember, digital circuit students, remember the 1 is true, right, and 0 is false. So when you write 1, the compiler understands that you are saying that this while loop will be always true. It will never false. That means it will always keep running. You will never be able to stop it unless you put the cross sign and close the window. Okay. Now let's try to understand the difference, that what it is doing. Let's see. Now let's see what it does. Let's keep it out of the loop. Let's say I put it here. Okay, now let's run the program. Now here, look at the difference. Let's say I put 6.5, and okay, now let me add a new line. There is a new line. I think we need a new line here. Let's add a we know the handle, right? I'm just saying we just want some new lines. Now let's run it. What it is doing, look at this. We just enter 6.5. You see here, it calculated, you see that it's calculated the area, but it's asking for the radius again. Now let's give another number. Calculated the area, another number. Calculated the area, another number. Do you see it keeps going? Okay, I'm giving different number. You see here what is going on? Because it keeps asking the radius, and it's because we are repeating those lines. Do you see what I'm saying? Do you understand what we did? Those lines are being repeated every time you just you calculate the area. He's asking. So this is the really beauty, because it will never stop. What do you think? You can calculate like million circle, area of circle, just by writing this code. That's it. But you have not written million lines. Just used one loop, and the same instructions are repeated, and calculating the same area just using the same formula. But again and again. Can you do 10? You see, we did not probably need 10 seconds to do the 10 radius, right? You probably cannot do it so fast, so accurate. You see, I tried to vary the number. You see here, 98.5203 I entered, and it calculated. I entered 89. You see, all different kinds of number. Sometimes I entered like small numbers like 7.5. Sometimes I entered big numbers. Doesn't matter, because as long as it's a fraction float number, it's calculated there. Okay. And for here, look at this again. So we just make a block of code. We want this part of the code to be repeated, right? That when it will ask you the radius, what is the radius, enter the radius, and then it will probably do the calculation. Just limit in one line. So we just made little enhancement here, okay? We just did little enhancement. Now we can do a lot of more enhancement. Okay, this was just some one example to motivate you. And remember, with your program, you can also enter comments. For an example, here, let's say you want to write that the formula of area calculation is entered. You know, when people write their program, okay, they write a lot of formulas, but they also try to write a lot of comments. You know, the comments are not the part of program, because when the program will be running, the program will never read your comment. But why do you need the comment? You need the comment for you, because later on, if you are reading your own program, you might be lost. You don't know exactly why you have defined some variable, why you have entered some formula, right? So that's why anytime we want to enter a formula, just write to backslash like this, and then you can write whatever you want. Most of the cases we try to write some meaningful comments so that anybody else who is reading your program, they understand that why you are entering some formula, or let's say by writing this line, everybody will understand that the formula you entered is the formula of the area calculation. Again, just as an example, when you see lab 8 and lab 9, you see in each of those programs there are plenty of comments, right? None of those comments are important for your program. I'm saying if you skip all those comments, your program will be still running. But we wanted to make sure that we understand, or somebody else understand, what you have written, why you are writing those. Because later on, when you are writing a 5,000 lines of code, you will forget why you have written those lines, or some formulas, or some variables. So that's why we wanted to make it more meaningful. Okay. Any questions so far? This is just starting, okay? We know that this is not a programming class, and we are not exploring the programming. This is just a basic introductory programming lab, so we'll spend the time from now to the end of the semester on lab 8 and 9. I know that some of you are done with 8. 9 is a little bit advanced, because in 9 you'll see those loops, conditional loops. Okay. So try the programs, and anytime you don't understand, just ask me, because I'll help you for sure. And also make sure we understand what we are doing, because the final is based on lab 8 and 9 only.
That's it?
That's it. It's too easy. Yeah. What do you think? Yeah. So, any question? No. Yeah. So he asked an interesting question, that what will be the condition of while loop? Now let's make it a little bit more enhanced. So probably we'll understand it better then. Let's say let's make a condition, because in this case we want the while loop is basically repeating your some lines of code, right?
Right.
Now, for an example,
Purpose of the one?
yeah, the purpose of one at this point is because we want the while loop to be true always.
Okay.
That's why we made it one.
Go.
Okay, now, in real life, you may not want some while loop to be true always, right? You probably want some kind of basic condition. Okay, now for an example, let's say you want to run the while loop for 2 times.
Okay.
How do you do it?
Put while 1 and then while 0 after 2 times?
No, let's try to see how we can do that. Now, for that, first of all, we need a parameter which will control the loop. Okay, let's say we need a parameter. Let's define a parameter. That parameter, we give a name, loop. So remember, we give a name. Doesn't matter what name you give, just a name. So let's say we give a name, and the name is loop. what type of variable it will be? It will be a whole number, because the loop will be running either for 1 time or 2 time or 3 time or 5 time, but it will never be running for 4.5 time, right? So the number will be whole number, and the data type will be integer. This kind of data are called integer, where you that the variables will take whole numbers. You know what I'm saying? 0, 1, 2, 3, 4, 5, -7, all the whole numbers. So those are called integers, and we define integer by int. Okay. Now let's make the loop equal to 0 at the beginning, and let's say here we change the condition. You see how we are changing the condition. We just write loop equals smaller than 2. Now what does it mean? It means that run the loop as long as the variable loop, the value of variable loop is less than 2. Look at how we initialized it. At the beginning we said the loop equals to 0, right? That means we said that at the beginning the loop will be 0. So that means that is less than 2, right? So at first it will be running for sure, right? And every loop, let's go inside the loop. After every loop, we are writing a line like this. What does it mean? It means that you are incrementing the value of the loop by 1. This is a operator called plus plus. Anytime you write plus plus, the variable is increased by 1. That variable. So at the beginning, the loop is 0, right? After first time it ran, it becomes 1. Still it is running because the condition will be true, right? The condition is true, right? Second time when it ran, it becomes 2 because the loop is increased every time. Do you think still it is true? Look at the condition. Loop must be smaller than 2. Do you see the condition? So can you guess that how many times this line of instructions will be repeated? 2 times. Twice. First time when it will be running, loop equals to 0. Second time when it is running, loop equals to 1. But the third time, loop becomes 2, conditions become false, it will not be running. Now let's check it. Let's check what it's doing. Let's check. Now, let's say you run it. Remember, this is the first time, right? Let's enter 7 point something. Now this is the second time, right? You see it asking for the radius again. 6.5. You see it's not asking for the radius again. Do you see it? You see it's not asking for the radius anymore, because the loop is done, because we just put the condition and it just took the radius twice, and it's not asking for the calculating the radius, calculating the area. It's not asking the radius again. Now you can enhance it. Let's change the enhancement and let's put this handle here so that the lines looks a little bit good. Let's put the handle here at the end of this now let's make it 3. Now it should be running 3 times, right? 1 for the first time when the loop is 0. Next time the loop will be 1, it will be running. The next time loop will be 2, it will be running. And then the last time the loop will be 3, it will not be running because it's not less than 3. Now let's look and see. It's running. This is the first time. Okay. So let's enter 8.7. That's the first time. Second time. This is the third time, right? You see it's not asking anymore. Do you see it? It's not asking for the radius anymore. That's how you can basically control the loop. You can use some variable, okay, and you can use all different types of simple, complex conditions to control the loop. Because remember, while we entered only 1, it was like true forever. It keeps running, keeps running, keeps running. Okay, it will never stop. But now we put some condition. Okay, run it for 3 times, run it for 1 time, or run it for 5 times. As long as we need, we just run it. Okay, you will see some kind of loops in lab 9. Oh yeah, sure. Any question? Say it again. You will not be able to compile it. There is no way you cannot compile it. You will need a compiler for sure. Either Borland or Turbo C, doesn't matter. Turbo C has a little bit limited, it's like a limited version edition because it doesn't have all the header files that the Borland C has. So that's why we prefer Borland C. It's like a superset. The compiler? The compiler is just again as a program. It's just like a program. Because the compiler is a program written in some other programming language. Because it was written when C was not there. That's what I'm saying? Compiler is written in another language which is it's stored in the computer. Just like yeah. Whenever you are writing a program, you save it, not the black window, because the black window is the output screen, right? It's dynamic, right? Because you are giving different different radius, and it's calculating the circle. That's a dynamic window. But the program, every time you just write a program, you will be able to save it either in your flash drive or hard drive or anywhere you want. And then later you can again open it and modify it or just run the same program. And there are ways that you can make your program into exe version. When you make a exe version, that does not require any compiler. If you click the exe, it will automatically show this black window and run it. I think sometime later I'll show you. If you are anyone interested, I'll show you personally how to get the exe. It basically creates the exe for each and every program, but it stores in some specific folder where you can find the exe, and then you can run the exe file. But to run the good thing about the exe is that you don't need the compiler. And bad thing is you'll not be able to edit it. And the size is a little bit larger. Any other question? Alright, so let's stop the presentation here. Remember, since we have a career fair today, as Lisa said, if you want, you can just leave the class at 12:15, and we'll stop the class at 12:30 because we know that we all want to encourage you to go to the career fair, and the career fair will, I think they will end at 1 o'clock, right? So at least you will get a chance to go there and see them and at least show your face and say hi, So we'll stop our class at 12:30, and after 12:15 you are free to go there, okay? So we want to really encourage you to meet them, even if you are not ready right now, at least to get a flavor of how the employer look like, when they are ready to give you the job, but you are not ready to take the job, how you feel, okay? That's really an exciting experiment. All right, thank you very much. And let me know if you have any question, because I know that you will probably have a lot of questions when you will be doing lab 9.